We're now successfully able to visit our running web application inside the browser, but there's one last little thing that I want to point out. I'm going to start my container up using the image that we've already built, but this time I'm going to start up a shell inside the container so that we can do a little bit of debugging inside there. Remember that we can start up a shell inside of most Alpine-based containers by running docker run -it, and I'll put down my container name of Stephen Grider simple web, and then I will override the default startup command with sh. Remember, this is a reference to the shell program. It will start up a shell that we can type commands into inside the container. Now you'll notice that I did not specify a port mapping here. It's because we are not going to actually start up the server. I just want to attempt to look at the files and folders inside the container. So I'll run that, and then we'll get a command prompt based inside of the root directory of the container. Now inside of here, I'm going to print out all the available files and folders with ls. So inside of here, you'll notice that when we did that copy operation, we copied into the root directory or the root folder of the container. And so in this root directory, we can see the Docker file, a packagelock.json file, which is automatically generated by npm, package.json, index.js, and all of our installed dependencies were placed into this node modules folder. And again, these were all placed into the root directory of this container. Now, this is definitely not the best practice. And the reason for that is that if we happen to have any files or folders that conflict with the default folder system, like if we have a folder called var or root or run or lib, super likely for us to have a folder called lib inside of our project, we might accidentally overwrite some existing files or folders inside the container, which is definitely not ideal. So we're going to make a little change to our Docker file. And rather than copying everything directly into the root project directory, we're actually going to copy everything into kind of a nested directory instead. Now, rather than just changing the copy command inside of our Docker file and saying, oh yeah, copy it into like some application folder or something like that, there's actually an instruction that we can use inside the Docker file that is specifically meant to address this whole issue right here of accidentally overwriting files or folders by copying into a root directory. So let's take a look at what the instruction is. So we can add the work_dir or work directory instruction into the Docker file and then pass a reference to a folder to it. Then any following commands or any following instructions that we add to our Docker file will be executed relative to this folder. So in other words, if we add the work_dir and then a folder above the copy instruction right here, it will make sure that we only execute, or excuse me, it'll make sure that when we actually do the copy instruction, it won't copy it into the work directory, excuse me, the root directory, it'll copy it into the directory that we have specified as the working directory instead. So let's try doing that right now. I'm going to add in an instruction of work_dir, and then we're going to use a folder of /user/app. So I'll say /user/app. If this folder does not exist inside the container, it will be automatically created for us. Now you might be curious as to why I'm using user/app. Well, to be honest, in the Node.js world, it doesn't make a tremendous difference where you put your application into in a Linux-based operating system. There definitely are places you don't want to put it, but at the end of the day, the user folder is a safe place to put your application. It's specified as the location for all of user home directories. Essentially, it's an okay place for us to put our application. Now, as I say that, there's definitely a lot of Linux diehards out there who would probably disagree with me, and they might say, oh no, you should put this into var, or you should put it into the home directory instead. So there is some disagreement out there on where the best place is for your application, but I can just about guarantee you that if you put it into user/app, you're probably going to be okay. Okay, so now we've added in the work_dir instruction. I'm now going to save the Docker file, and then we'll flip back over to our terminal. I'll exit the running container by typing in exit, and then we're going to make sure that we first rebuild our container, and then we will try to relaunch it. So I'll do a rebuild with docker build dot. Oh, let's not forget to tag it. So docker build -t your Docker ID /simple web, and then a dot. There we go. So we're going to rebuild it. Now, one thing that you'll notice is really interesting. Because we made a change to an instruction above the copy and npm install, everything after that instruction has to rerun from scratch. So we cannot use any cached versions. In other words, the npm install command has to run again and reinstall all of our dependencies because we cannot use the cached version of that step. So we got our output here. Let's try starting up our container again. I'll first start it up in normal mode and try to visit it inside my browser. So we'll do a docker run -p to set up a port mapping, and we'll map 8080 to 8080. And then the container that I want to run is Stephen Grider /simple web. So we'll run that, and then I'll go back over to my browser. I'll try to visit localhost 8080. And yep, it looks like we're good to go. I can refresh the page. And if we also try to start up a shell inside the container, we'll see that all of our project directories, or excuse me, all of our project files are no longer in the root directory. To do so, we can either rerun the docker run command with the IT and sh attached to it, or we can use that docker exec command. You'll recall we can use docker exec to start up a second process inside of a running container. Let's try doing it that way just for a little bit of variety. So I will open up a second terminal window. I'll get the ID of that running container by using docker ps. So here's the ID right here. And then we can attach to that container and start up a shell inside of it by using docker exec -it, the ID of the container, and then the program that we want to run inside of it, which in this case is shell. Don't forget the IT right here is to attach standard in and a nice looking terminal to the shell that starts up. So I'll run that, and you'll notice that we enter directly into the user/app folder because we had set up that working directory previously. That workdir instruction right here not only affects commands that are issued later on inside of our Docker file, it also affects commands that are executed inside the container later on through the docker exec command. So if I now do an ls right here, I'll see all of my project files and folders nicely isolated inside of this single file. And I can change back to my root directory by doing cd /, print out all the files and folders there with ls, and I'll see that I do not have any possible conflicts going on. We have nicely spaced our application, or kind of isolated our application into this folder right here. All right, so that's pretty much it. Looking pretty good. Now, believe it or not, there is one last little thing that I want to look at. So let's do one more quick break, and we'll come back in the next section and do one quick last little thing. So I'll see you in just a minute.